Hey, good morning everybody. I am not going to be in today, so instead I'd like you to watch this video about energy and our slideshow here, and I'd like you to go through the worksheet which has been posted in Google Classroom. I'm also going to post this slideshow separately, so if you want to go back and look at the slideshow but not listen to the whole video, it will be there. So we're moving into our physics unit and we're going to be talking about energy, and there are lots of different kinds of energy. Here's our little cat friend here, preparing to pounce. Okay, these are a list of examples of different forms of energy. Don't feel like you need to write all of these down. There's no need for that. I just wanted you to see that there are a lot of different kinds of energy out there. We're going to discuss explicitly the ones I want you to know and be able to work with. Okay, so energy, the general definition of energy is the ability to make a change or do work. So to think about this in practical terms, you need some energy to do construction. You need energy to do housework. And you're going to expel that energy as you run around doing things. So then work is the transfer of energy. That makes sense, because if you start and you have a lot of energy and then you go out and you spend several hours chopping wood, you're not going to have so much energy when you're done. You've transferred it. Work is force times distance. So there is a mathematical equation, and we can calculate work, and the unit for energy is called joules. Okay, there are two big categories for energy that we're going to be working a lot with. And we've got potential energy and we have kinetic energy. So remember our skateboarding dude hanging here on the edge of the skate park, because I'll refer to him in a minute. Okay, so kinetic energy is the energy of movement. So like we discussed, that temperature is a measurement of kinetic energy. So a measurement of how fast those particles are moving. Kinetic energy itself is the energy of movement. So skateboarder dude, when he is moving through the skate park, he has kinetic energy. Now, mass has an effect on this. The larger the mass, the more kinetic energy. So if you can think about this like if you were in a room and there were a bunch of football players running around and one of them smacks into you, that's going to have a lot more force than if you were in a room with a bunch of toddlers and one of the toddlers smacked into you. Football players, much more mass. Speed also has an effect. So the faster you're going, the greater that kinetic energy. That relates directly back to the definition of temperature, temperature being a measurement of kinetic energy, and the higher the temperature, the higher the energy. So speed is all about how fast are those particles moving. Potential energy. So this is the official definition from the internet. Potential energy is the energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, or other factors. So what this means in plain English is that any object, any being, anything has energy which is stored and not being used right now. It has the potential to be used later. So something to think about is gravitational potential energy. This is the amount of energy something has when it's up high. So think about a little kid on the slide, or skateboarder dude. He was right on the top of that slope in the skateboard park. He had the potential energy because he was up high and he could be sliding down and turning that into kinetic energy. So the higher the height and the higher the mass, the higher the potential energy. So the further up you go, the more gravitational potential energy you have, because the higher you are, the faster you'll get going when you go down, and that's kinetic energy. So these two things, kinetic energy and potential energy, are very related to each other. Okay, so now here's another kind of potential energy, and we have elastic potential energy. And this is energy absorbed by an object that can stretch or shrink. So Katniss here has her bow, and her bow has elastic potential energy. As she pulls back on the bow there to shoot her arrow, she is storing up elastic potential energy because her bow is stretching from her pulling on it. The more she pulls it, the more potential energy it contains. So think about it. If she just pulled it a little bit, the arrow's not going to go very far. But the farther back she pulls it, the farther that arrow has the potential to go. Chemical energy. This is energy stored in chemical bonds, and this is pretty essential to life as we know it, because we're talking about food. Food is full of chemical energy. We'll talk about this a lot in bio next year. We eat food because it has chemical energy stored in it, and we use that chemical energy to move, to run around, to think, to breathe. All of these things require energy. And it's stored in the chemical bonds that we've been talking about in our last unit. The ionic bonds, the covalent bonds. What we do when we eat something is we break those bonds and we turn it into energy we can use to do things. Every time you break a bond, a bit of energy comes out. Now, as in anything, we must have some rules. And we have the law of conservation of energy, which means that energy cannot be created nor destroyed. The total amount of energy in the universe is constant. We can change it from one type to another, but we can't destroy it. It's always somewhere. Maybe we don't know where we left it, but we always have it. This is based on one of those toys that bops back and forth. Okay, so let's look at mechanical energy. Mechanical energy, ME, is gravitational potential energy plus kinetic energy. So GPE plus KE is the gravitational and the kinetic. So check out skateboarder dude here. When the skateboarder dude is at the top of the hill, notice that he has 0 joules of kinetic energy because he's not moving yet. But he's got 50,000 joules of potential energy because he's so up high. Now look at the first one here, and now he's going down. So we've converted some of that 20,000, some of that 50,000 to kinetic energy. So we got 20,000 joules of kinetic energy because he's moving. And we still have 30,000 of potential energy because he's still up the hill a ways here. But notice 20 plus 30 is 50. So we still have the same amount we started with. Here is skateboarder dude a little lower. And now we've got more kinetic energies and more time to build up that speed. And we've lost more potential energy because he's closer to the ground. But then we're going to jump. And that changes again, that ratio. Now we've got less kinetic energy because he's been going up. He's losing a bit of speed here. And we've got more potential energy. And then finally, skateboarder dude here hits the ground. And now he's got no potential energy because he's completely at sea level here. No more hill. And all of the energy is in speed. All right, so that is it for this slideshow. Pay attention to this stuff, in particular the bits about elastic potential energy, because the very first thing we are going to do in our physics unit is build catapults. All right, guys, have a great day and have a great weekend, and I will see you on Tuesday. Tuesday, we're going to review for the test next Friday on wrapping up that chemical reactions unit. See you soon.